So this is problem 12 of the AIME. 9 delegates, 3 each from 3 different countries, randomly select chairs at a round table that seats 9 people. Let the probability that each delegate sits next to at least one delegate from another country be m over n, where m and n are relatively prime positive integers. Find m plus n. In this case, it seems better to use complementary counting, where we count what we don't want. So if at least one person is surrounded by people from their country, that means all 3 delegates from one country are sitting together. So we'll find out how many ways that can happen. First, we know that the total possibilities is 9 for seating the delegates, assuming they're distinguishable, is 9 factorial over 9, since the table can be rotated, so this is 8 factorial. So let's consider seating one country's delegates all together. So we can glue their 3 delegates into a super person in 3 factorial ways. And then we have this super person and 6 other delegates, which can be arranged in 7 factorial over 7 ways, so which is 6 factorial. And since there are 3 different countries, you can choose the one country in 3 ways. So it's like this. Now, of course, in this case, we've overcounted the cases where 2 countries are sitting together. Two countries are sitting together, so we'll subtract those. So first we'll count this. 2 countries are sitting together. We have 3 factorial times 3 factorial ways of arranging the 2 countries into 2 super people. And so this would become 4 factorial ways to arrange those 2 countries in the remaining 3, because the table can again rotate. And once again, you can pick those 2 countries in 3 different ways. But when we subtract out these, we've also undercounted the cases where all 3 countries sit together. So we'll count those. And of course, there are 3 factorial times 3 factorial times 3 factorial ways to arrange them. And then of course, there are 2 ways to arrange them around the table. So we do this minus that plus that. And if you work out the math, you will eventually see that this leads to 10,800. And 8 factorial is 40,320. So the probability of at least one set of 3 delegates from one country sitting together is this over 40,320, which reduces to 15 over 56. And since this is what we do not want, and the answer is asking us for what we do want, we subtract that from 1. So the probability we want is 41 out of 56, and as usual, it asks for the sum of the numerator and the denominator, which comes out to 97.